In this video, we're going to be talking about parent functions, shifting, reflecting, and stretching graphs. So here we see 6 commonly used functions: linear functions, absolute value functions, square root functions, quadratic functions, cubic functions, and rational functions. Now, in order to talk about transformations, we first need to talk about what is the difference between a rigid and a non-rigid transformation. Well, a rigid transformation will have no change in the shape's size. It will just move left, right, up, down, or rotate. A non-rigid transformation, though, is where the shape will actually change size, like in a dilation. So we're going to go through the different types of transformations that we might come across, and some different examples and how they might look. So to begin, we're going to talk about horizontal transformations, and that shifts the graph left and right. Notice here the h value is on the inside of the function with the x value. And when we see a minus, it moves in the positive direction to the right. And when we see a plus, it moves into the negative direction to the left. When it's on the inside, it can be very difficult to remember which way you're supposed to move. So I like to say that the h is a liar. It's a hypocrite. It says one thing and does another. And that helps me to remember. Let's talk about vertical translations. That's where it shifts the graph up or down. Notice here that our k value, which is what shifts it up and down, is on the outside of our equation. It's not in with the x. And if we have a plus, it means up, and if we have a minus, it means down. So here, our k is like an honest kid. And so it moves it up and down, and what it says is what it does. Reflections can happen over the x or the y-axis. Notice here that it's all about where that negative sign is. If it's on the inside with the x, it will reflect in the y-axis. And if it's on the outside, it will reflect in the x-axis. Here we see an example of what that might look like. So a reflection in the y-axis and a reflection in the x-axis. Let's talk about horizontal stretching and shrinking. When we're dealing with horizontal stretching and shrinking, it means that we are multiplying by a factor. Notice that when our factor is a whole number, we're actually shrinking by its reciprocal. And when we're multiplying by a fraction, a number smaller than 1, we're actually stretching by its reciprocal. Notice in this example that we see that it's moving wider, right? It's moving away from our y-axis, or it's coming closer to our y-axis. So a stretch would be going wider, and a shrink would be moving closer to. Now, if we're talking about vertical stretch and shrinks, notice here that we have a different factor. It's on the outside. We've denoted it with a different letter. And when we have a whole number, or a number that's larger than 1, on the outside, that we are stretching by that factor. And when we are multiplying by a number that is smaller than 1, we are shrinking by that factor. There is no manipulation. So notice the difference between the vertical and horizontal stretch notation. For the horizontal stretch and shrink, the numbers are on the insides. And what looks like it should be a stretch is actually a shrink. And what looks like it should be a shrink is actually a stretch. Hence, when something is on the inside, it's a liar, it's a hypocrite. It says one thing and does another. But on the vertical stretch and shrink, if it looks like a stretch, it's a stretch. If it looks like it's a shrink, it's a shrink. Visually, this is what that looks like. We're either pulling away from the x-axis or bringing it closer to the x-axis. So a stretch would be pulling it up, making it narrower or skinnier, And pulling it down towards the x-axis is going to actually make that wider. These a, h, m, and k values don't just relate to the square root function. Take a look at our 5 functions here. Do these functions look familiar? They match up with our parent functions at the top. We have our absolute value function for number 1, our quadratic function for number 2, we have our square root function number 3, our cubic function number 4, and our rational function for number 5. So these transformation rules don't just coincide or go with the square root function, but they will work for all of our parent functions. So it's important to learn that notation and to understand that notation because it applies to so many different types of functions and equations.